Hello friends, welcome to CS Digest. So in this particular video we will be starting with the main topic and we will be diving into the main topics of theory of computation. So first one is finite automata. So what is a finite automata? Finite automata is basically a it is made up of five tuples which are known as denoted as m. We can denote it as m. So the five tuples are q, sigma, delta, q naught and f. So we will study each of them in detail. So what is q? So q is nothing but it is a non-empty finite set of states present in the finite control. Okay, so different non-empty finite set of states, for example q0, q1, q2 and so on. So these are set of this is non-empty finite set of states. You will understand this more when we will design more DFAs in our next videos. But this is the introduction part of finite automata. Okay, this is the theoretical part. Okay, so these are non-empty finite set. This is important. The state should be a finite set. Okay, the next one is sigma, which is a non-empty finite set of symbols which can be passed to the finite set of machines. Okay, so they are nothing but non-empty finite set of symbols. Okay, next is q naught. Q naught is nothing, it is initial state or the starting state of our finite automata machine. Okay, we will study all this again when we will study about the design of finite automata. Then you will understand it more thoroughly. Just now try to understand the theoretical part. Next, f is it is non-empty set of final states. Non-empty set of final states. So basically in our DFA or NFA particularly in DFA there are two states. For example, we are designing like this. Okay, so this is initial state q naught and this is final state f. If we denote it using two circles, so this is a final state and this is the starting state. Okay, now the last one is delta. It is nothing but a transition function. So what a transition function does is it takes two arguments. Which two arguments? A state and an input symbol. So it takes these two arguments and it, after using these two arguments, return a single state. This is what is the function of transition function. So transition function in finite automata is described as q into sigma. It gives returns a single state. So there are two arguments, q and sigma, where q is a state and sigma is an input symbol, and q is the single state which is the result of these two arguments. So this is how a transition function in finite automata is defined. Okay, now there are few things we should note down and keep in our mind. So first one is at any instant of time automata will be only one state. At one time it can't be two states. For example, this is a DFA. So either it is this state or this state at a time. It can't be these two, both of these states. Okay. Second one, the next state of automata depends on the present state and present input. So this is the next state of this. So this will depend on this state and the input symbol which we give here. For example, we give A. So it will depend on these two arguments. Okay. Third one is transition function describes the change of the state during a transition, which we studied here. Okay. And the last one is the automata scans or reads the input string from left to right, and only one symbol at a time. It can't read from right to left. For example, this is our automata. So this is initial state, this is final state q1, this is q2, this is q3, another final state. We can have more than one final states. Okay, so here we will scan from left to right. We will go from q0 to q1. For example, input symbol is A, here is B, here is A again. Okay, so we will scan from left to right. We can't go from right to left. We can't go from q2 to q0 or q2 to q1. We will always scan the finite automata machine from left to right. Okay, now from the next video we will study about how we can represent the finite automata and different types of applications of finite automata, and then we will dive into our NFA. Okay, thank you.